Boys and girls, moving on to example 4. We're still going to be solving our equations. We're just going to be applying factoring, okay? So our goal is still to solve for a trig identity. So first thing you want to do is set it equal to 0. So I'm going to be doing that by subtracting 3 cosine, subtracting 3 cosine of x to both sides. So I'm going to do it to the left side and the right side. These are not like terms, so I really can't combine them. So what I'll do is I'll rewrite it as 2 cosine squared of x minus 3 cosine of x equals to 0. Okay? And then I can't combine them, but what I can do is factor out a cosine. So if I factor out a cosine of x, then I'm left with 2 cosine of x minus 3 equals to 0. Okay. Then pretty much what you're going to do is you're going to apply the zero product property. So it's almost like two factors because these are both factors. Okay, this is a factor, cosine of x is a factor, and 2 cosine of x minus 3 is a binomial, but consider this a factor, equal to 0. So you're going to set each one equal to 0 and just solve for them individually. Okay, so what I'm going to do is set this one equal to 0 and set this one equal to 0. So what it'll look like is cosine of x equals 0 and 2 cosine of x minus 3 equal to 0. Okay, again, zero product property. So this one, I can pretty much get an answer already, but we're going to save it, okay? But this one's done. You've already isolated your trig identity. This one, we need to isolate our trig identities. The first thing we're going to do is add 3 to both sides. Then you're left with 2 cosine of x equals 3. And then, of course, divide by 2 to both sides, okay? So cosine of x equals 3 over 2. And so now, now that we're done isolating our trig identity, then we can use the unit circle, okay? But right off the bat, boys and girls, and I'm hoping this is already obvious, we already know that there's no angle that will ever give us 3 over 2. So believe it or not, that actually helps us out because this one will have no solution, okay? So we don't have to bother solving for this one. So this one's done, okay? There's no angle that will give us 3 over 2. So all we have to do is solve for this one. So if you look at your unit circle, once again, we're working with cosine. So that's our x value. That gives us 0. So you guys know that that happens at pi over 2. And then that happens at 3 pi over 2. Okay? So x equals pi over 2 and 3 pi over 2. Whoops, something happened out there. But again, they didn't restrict our domain. So what that means, cosine is an infinite trig function and it occurs, we're going to have multiple answers, okay, multiple solutions. So imagine if this is continuous, it's going to keep happening at pi over 2, 3 pi over 2. And then it's going to do another period, happens at pi over 2 and 3 pi over 2. Basically, it's just going to keep going on and on and on. So we can just write x equals pi over 2 plus n pi. And the reason why I'm just multiplying by pi because it literally happens here. And if I add a pi, it'll happen here. Here. If I add a pi here, if I add a pi, it's just going to keep going back and forth. Okay? So that would be my general solution right here. Okay? This would be my answer. All right, awesome. Let's move on to one more. Okay, so for our next example, again, we're going to be solving an equation, and this one reads 2 cosine squared of x minus 5 cosine of x plus 2 equals 0. Okay, and then if you notice, they gave us an interval of 0 to pi. So when we find our solution, we're just finding our solution over one period, and that's it. Okay, so we don't have to do multiple solutions. Okay, so the first thing I notice is we have 2 cosines, okay? So cosine squared x minus, or 2 cosine squared x minus 5 cosine of x plus 2 equals 0. This is considered a quadratic equation. So just to refresh your memory, I'm going to show you what property you're going to be using, and it's from factoring quadratics. And you did learn them in an integrated 3. It's just been a while. So let me show you. Okay, so depending on how your teacher taught you, this is a quadratic equation, and you solve quadratic equations by factoring. We usually call that AC method, or some teachers might call it the X factor. And this is how I normally taught it, just so you understand what you're doing. So A, B, and C are coefficients. A can never be 0. And basically what you're going to be doing is you're going to be looking for two numbers that multiply to give you whatever A times C is. And those same factors will add and give you whatever B is. Okay? So let's actually apply it to this equation. So our equation that we're working with is 2 cosine squared of x minus 5 cosine of x plus 2. So the first thing we're going to do is identify our A, B, and C coefficient. Okay, so our A coefficient is 2. Our B is going to be negative 5. And then our C will be 2. Okay, you always want to keep the sign that's in front. Okay, so our X would be cosine. Okay, cosine. So if you multiply A times C, that gives you 4. And if you just write down B, that'll give you negative 5. Okay. So think about this. You're looking for two numbers that multiply and give you positive 4. But when you add them, you'll get negative 5. So when do you multiply two numbers and get with the positive, but then add and get a negative? When they're both negative. Okay. A negative times a negative is a positive, and if you add two negatives, you should still get a negative. Okay. Now, did you figure out those two factors? You should have gotten 4 and 1. 4 and 1. Okay. All right. So how do we write this? Again, this is like integrated 3 concept, and we used it a couple times. But when it comes to factoring, the way you write it would be this way. Cosine of x, and then what you want to write is you want to write down your factors. So minus 4, and then cosine of x minus 1. But hold on, I didn't put any parentheses or anything, because I want to remind you, when A is greater than 2, you basically want to repeat this. And again, this is a concept we've already used. So you're going to write 2 cosine of x minus 4 and 2 cosine of x minus 1. Okay. And so if you were to do FOIL and multiply your first terms, you would end up with 4 cosine squared of x. But we don't want 4 cosine squared of x. We just want 2. So you're going to have to get rid of one of the 2's. And if I had to choose between the first or the second, I would get rid of the first one. And the reason I would get rid of the first one is because when I divide by 2 to both sides, I don't end up with fractions. I end up with whole numbers. So my factors are cosine of x minus 2 and 2 cosine of x minus 1. Okay. And of course, equals to 0. And remember, the reason why they're equal to 0 is because we've now factored out everything on the left-hand side. We've basically factored it out, and it was equal to 0. Okay, so now let's solve. Okay, so now that I have my factors, I'm going to set each one equal to 0. So here we go. So now we're going to have cosine of x minus 2 equals 0, and 2 cosine of x minus 1 equals to 0. And again, we're just going to solve for each one. So in the first one, all I have to do is add 2, and then I end up with cosine of x equals 2. Okay. And then in the second one, I'm going to add 1. And then I end up with 2 cosine of x equals 1. and then of course divide by 2. So then I end up with cosine of x equals 1/2. And I don't know why they just kept giving us cosines, but we're just working with cosines for some reason. Okay, but now I'm going to show you your unit circle. Now, hopefully you have most of these points memorized by now, but there is nothing on the unit circle that will ever give me a value of 2. So I can tell you right now, this one's not going to have any solution. Okay? So that means all we have to do is concentrate on our second equation. So cosine of x equals 1/2. So when is this going to happen? Cosine of x equals 1/2 will happen at pi over 3 and will also occur at 5 pi over 3. Okay, so pi over 3 and 5 pi over 3. And that's it. So since they only asked us for solutions over one period between 0 and 2 pi, again, I don't need a general solution. So my answers will happen at pi over 3, comma, and 5 pi over 3. And these are my solutions. Okay? And that's it. Okay? That's it. Okay, so 4 and 5 are similar. So now you have enough to try the 2 checkpoints. Okay? And as always, boys and girls, if you have any questions, just jump back in the chat and I'll help you.